Correct? Both bodies are having same emission rate. So that's the sigma A E1. Sigma A T2 raised to 4. ये गया, ये भी गया. तो even 0.01 E2 I write this as multiplying by 100 on both sides. 3 raised to 4 है. 3 square 9, 9 square 81. So I got T1 is a 92. Three raised to 4. 3 T2. Okay. So T2 is T1 by 3. Wait यार, बाद में कॉपी करो. थम जरा 1 मिनट. हाँ. 5802 by 3. Correct? 3 into 1 3. 3 into 9 27. 3 into 9 3 into 4 Kelvin. So temperature of body B is 1934 Kelvin. हाँ, option 1. Come back. Up to this you have understood?
Yes.
Oh come on. Now let me come back to that wavelength part. Then I can't let you look at that statement, understand it very carefully what I am saying. The wavelength corresponding to the maximum spectral radiancy in the radiation from B is shifted from the wavelength corresponding to maximum spectral radiancy in the radiation from A by 1 micrometer. So the meaning I have here. Look here. First of all, I got my T1 greater than T2. Is it clear? So I got my T1 greater than T2. Therefore, the peak lambda 1 will be less than lambda 2. Is this clear? And ह्यांच्यातला difference 1 micrometer. I guess micrometer है ना ते. Correct? It is shifted by 1 micrometer. What does that mean? Listen. That's energy density. Or wavelength here. Okay, so now the meaning of the problem is lambda 1 is less than lambda 2. Come on. This is at temperature T2. See carefully, temperature T2 कितने आ रहे थे? 1934. Correct? You have plotted the graph at 1934. Is this clear? You got the peak over here. Is it clear? This is your lambda 2. And the meaning of the problem is your lambda 1 is shifted from it by 1 micrometer. It will be on the left. Because chota hai lambda 1. Is this clear? So your lambda 1 is on this side. Oh, that's my lambda 1. You got that?
Yes.
Our difference है ना 1 micrometer है. The question question arises, can I find lambda 1, lambda 2? Answer is yes. How? Good. Lambda 1 T1 will be equal to lambda 2 T2. Lambda 1 T1. Now, this is my first calculation. ये मेरा second था. हाँ, check. Now, from Ben's law, lambda 1 T1 equal to lambda 2 T2. Is this clear? Lambda 1, lambda 1, lambda 1, I don't know. T1, I'll write T1, come on. And lambda 2, I'll write 1 micrometer plus lambda 1. T2 काहीतरी काढलाय आपण T1 by 3 चे व्हॅल्यू टाकू नका. It's a T1 by 3. Is this clear? Calculation simple रखो. You got that? Yes or no? तो T1 गया. This is 3 lambda 1. Come on. So 3 lambda 1. 1 micrometer plus lambda 1, that's 2 lambda 1 is a 1 micrometer, so my lambda 1 is 0.5 micrometer and lambda 2 will be equal to 1.5. 1 का gap है ना तो ये बावला करो हाँ so that's 1.5 micrometer. Is this clear? Yes or no? Lambda 1, lambda 2 कौन option है वो? Lambda 2 is 1.5 micrometer. ये दोनों option correct है दीजिए. Understand? हाँ actually एक minute I mean listen carefully. This type of I'm not saying this type of MCQ will not come in your paper. This question has a very high chance to be in your paper, but the options 2 will not be correct. One of them will be then A and B both. हे काय माहिती हाँ मी जर बघायला तो त्याचं IIT something 1980 त्यावेळेला आहे ना not up to 1980 विसरून जातो मी. I'll tell you up to I think 2012-13 we used to have MCQs in IIT, especially in advanced where more than one options are correct. That's why if you will see old papers, see carefully of JEE, you will find that 2 options are correct. Means त्यांचा तो pattern means only one option is correct, those are MCQs. Then section B was more than one options may be correct. Are you getting it? Okay, it was like that. तशामध्ये असं question means suppose if your paper has to be contain this question, then this will be answer, this will be answer, this will be option A, this will be option C, and option D will be both A and B, A and C, something like that. That's all. Is this clear? Okay. Complete this. And now we'll go to MTG. I'll just revise the formulas what I have done, and I want you to solve that MTG right now here. किया समझ रहा है? Sure. पक्का. $59 राहिला असेल कदाचित. सोपा आहे. So combination Newton's law and ms theta. Done? Done? Now listen, what I am saying, please pay attention. Listen, look at that MCQ number, I guess, 59. This is done? Look here. Look here, what I am saying, the problem is this way. You know, there is a sphere whose density is rho. I have taken, he has given symbol as a D for the density. Specific heat of the material of the sphere is a S. And the radius of the sphere given to you is a R. The temperature of the sphere is T, capital T, and it is kept in a cold surrounding. It's kept hanging. T is greater than T now. So check. T is greater than T naught. Then the question is rate of fall of temperature. See carefully. Rate of fall of temperature for that sphere will be proportional to. It's this way. Check. If the temperature difference is delta T, and surrounding difference is a T naught, then the rate of fall of temperature will be, rate of fall of temperature means d theta by dt. Rate of fall of temperature Tt by T. Rate of fall of temperature. Party temperature है time है. Is it clear? We used to take d theta by dt as a symbol. What will be the formula for this? Temperature of surrounding is T naught. Temperature of the sphere is T. It's kept hanging. This is insulating. Don't worry. So no heat loss. That thing is of no significance in this. dq by dt. I'm not sure what the sigma I can take. Newton's law, sigma A E look here, please pay attention. त्याच्यामध्ये ना बायनॉमियल एक्सपेंशन यूज करा. फाइनल ऑप्शन इज इट कंटेनिंग टी नॉट और टी. इसे एलिमिनेट करें. टी नॉट है ना, तो टी एलिमिनेट करूंगा मैं. तो टी इज इक्वल टू टी नॉट प्लस टी. यू गॉट दैट? यस और नो? सो यू रिमेंबर dq by dt आई यूज्ड टू राइट. उसने स्पेसिफिक हीट एस दिया है, डेंसिटी दिया है, मतलब वो सब लाना पड़ेगा. करेक्ट. तो dq by dt will be mass, specific heat, and this theta is a temperature. Correct. So that's the dt by dt नंतर लिहून घे. Correct. Mass, specific heat, dt by t, sigma area of the sphere 4 pi r square. जो टर्म्स तुम्हें दिए हैं, try to get your calculations in that. Is this clear? T raised to 4, I don't want T. Mass, what you will write? Density into volume. Density into volume into specific heat, d theta by dt, sigma 4 pi r square. This check. आता ना हे सॉल्व करायचे दोन मेथड आहेत. One, either you go by binomial or you use a simple formula. Binomial expansion will be very lengthy. It will involve 5 terms. What I will do is I'll write it this way. Check. From this bracket I am taking T naught common. You understood what I have done? ओए समझते हैं ना? हाँ? हाँ. हे सबस्टिट्यूट केलं मी.
नाही मला दिसतच नव्हती.
आता दिसतंय? Okay, listen. Minus T naught raised to 4. You got that? Density, volume, 4/3 pi r cube s dt by t. It's a sigma 4 pi r square. This I write as Correct? Is it clear? So your 4 pi will cancel. I guess final option is 5 to 10 आए. Is this clear? हाँ? तो कचरा पहले निकालो. गया. एक r square भी जाएगा. So here you are left with d s r by 3 dt by t sigma t naught is to 4. I'll take common check plus delta t by t naught raised to 4 minus 1. You got that?
Yes.
Up to this it is clear? Yes or no? बाद में कॉपी करो यार, please. Now listen very carefully. After that, you know, this I have to solve very tactfully. I am saying either this will be done by binomial expansion, correct? But I will avoid that because it will involve 5 terms.
Yes.
Check, my delta t is much lesser than t naught. That is what he has said.
Yes.
So delta t upon t naught is much less than 1.
Yes.
And I have told you the formula 1 plus x raised to n is approximately equal to 1 plus nx if and only if your x is very less than 1. Correct? So this term I am going to write 1 plus delta t by t naught raised to 4 as approximately equal to 1 plus 4 delta t by t naught. Is this clear?
Yes.
Yes or no? T naught cube है ना final में ज़्यादा मत. Correct? तो dt by t and that's your s r d by 3 is equal to sigma t naught raised to 4 into 1 plus 4 delta t by t naught minus 1. This is gone. So dt by dt is equal to 3 sigma t naught raised to 4 upon s r d 4 delta t by t naught. 4 into 3 12 sigma t naught cube delta t upon s r d. Is it clear? Yes or no?
Yes.
Clear? आता घ्या लिहून. स्पेसिफिक घेतली आहे मिसप्रिंट किंवा वन घेतली असेल. कधी ना एक मिनिट ना. Hello, listen. Sometimes you may find J here in the denominator. Capital J. Listen. What I am saying, you may find that J sometimes in the denominator. Don't worry about that. From where it comes, you solve it normal method and just at the end put that J. I'll tell you, काय माहिती ही heat आहे. He might have taken that in the calories. Are you getting it? What I am saying? This dq, he might have taken that in the calories. And हाँ dq है ना, that in Stephens law we write in joules. The calorie is a unit selected for convenience. That is not the NCS unit. Is this clear? Understand it very carefully. So the thing is that तो J तो mechanical equivalent of heat. Finished? तुम्हाला समजतं ना काय इकडे आम्ही येऊन सांगतो ते वेगळं मांडलं. सीताजी पक्का समझ रहा है? Okay, so we'll now start with MTG. What I mean here is you have to solve it. मी त्या पार्टनर आहे बस कर भूताच्या बंगल्याकडे. Because spring there are very such structures in the heart of the city. तो मुंबईमध्ये राहणार नाही. So that value of that plot in Mumbai will be something like in crores and crores. पैसा रहेगा ही नहीं. Done? 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 Yes, now I'll give you the list of formulas of KTLB, what I have done so far. Listen. And I guess up to problem number 11 I have done. पहले मला वाटते 11 जरी मी केले 10 का 11 check. I have done that. Maybe 8 or something like that. Correct? 8 or 9 something I have done. Listen. 1 minute to bus. First, wait. All formulas I have used. Pay attention. एक मिनट या that is how ideal gas is written. Ideal gas equation where your K is the meaning of the symbols is same. N is the total number of molecules, N is Avogadro's number. That's equal to mass of the gas upon molecular weight. Correct? K. What is K? Boltzmann's constant, that's the R upon A. Huh? Is this clear? Wait man. Second. Pressure. 1/3 rho. CRMS square. Density is mass of the gas upon volume. Mass of the gas is n number of molecules into mass of each molecule, small m. Upon volume, please pay attention. Then CRMS root of by molecular weight. Wait. PV is equal to nRT. So RT I will write PV upon N. Is this clear? Yes or no? And N into MW is mass of the gas. Is it clear? Okay? You have understood this calculation or not?
Yes.
PV equal to nRT to RT I will write as PV upon N. And N into MW is capital M, mass of the gas. Correct? After that, ये RMS velocity थी. Listen. Specific heat. That I have done already. CPCV, you know, at a constant pressure, at a constant volume. Increase in internal energy delta U is a N. CV delta. Is this clear? Second, work done.
पाटील कोण आहे? मला भेटशील नंतर. हो ब्रेक झाला.
NR delta T. Is it clear? Yes or no? Listen. Correct? Radiation चे formula मी देऊ already I think I have given in thermal properties. Correct? They are simple. A plus R plus K is 1 and all that Stephen's law, Boltzmann's law, and Weinstein's law and all that. Is this clear? So those we have already done. So these are the main formulae from KTOG. One more set of equations you need, that's the equations of energy and degrees of freedom. Wait! 7. Oh come on man, equation for energy is, listen yaar, 3 by 2 PV. That is equal to 3 by 2 nRT. This is energy of n moles. So energy of a single mole, check. Energy of 1 mole is E. 3 by 2 RC. This is energy of 1 mole that contains Na molecules. So it is energy of Na molecules. Come on man. It is energy of Ne molecules. So energy of a single molecule. Correct? Is energy of single molecule. How much is that? 3 by 2 R upon Na into T. That's 3 by 2 kT. Is it clear? Energy per unit volume will be 3 by 2 P. Correct? And this N, suppose I write 3 by 2 nRT, 3 by 2 N. Mass of the gas upon molecular weight. This is energy of the gas of mass M. Sometimes your problem will be find energy of mass or find energy of 50 kg of oxygen or 30 kg of oxygen, something like that. Or it will be 15 liter of oxygen. Then you go in terms of volume, then you go in terms of mass. Is it clear? That's the 9th formula. Nature of the gas. If the gas is a monoatomic, come on. Cp, Cv, you know. Mono, diatomic, and gamma. For monoatomic it's a
3 by 2 R.
Cp,
5 by 2 R. 5 by 2 R.
for diatomic
5 by 2 R. 7 by 2 R.
Is it clear? Low temperature. High temperature la 709. Okay guys. Okay, is it clear? Linear triatomic.
7 by 2.
Linear triatomic. एक तो 3 कैसे
7 by 2.
7 by 2 R. 9 by 2 R. Non-linear triatomic. Is this clear? Then, if two gases you are mixing, then Cp of the mixture N1 Cp1 plus gamma of mixture. Is this clear? Yes or no? If two gases are mixed and if number of moles are remaining constant, energy is conserved. Wait! Two gases, N1 T1, number of moles at temperature T1, and number of moles N2 T2 are mixed. Come on, कुछ बोला ही नहीं है क्या मोनोएटॉमिक क्या डायटॉमिक. Then go by number of moles conservation. Total energy is conserved. I mean to say 3 by 2 kT 1 is the energy of one molecule of first gas. and such N1 molecules are there. 3/2 T is the energy of one molecule of second gas, and there are such N2 molecules. Correct? N1 plus N2. 3/2 K. T is the temperature of the mixture. I want 3/2 K gaya, 3/2 K gaya, 3/2 K gaya. Is it clear? पहले इधर देखो. The temperature of the mixture you write as. क्या आठवते क्या? हाँ, you remember I have done this.
Yes, sir.
Yes or no? I was teaching it. Remember when you were desperate to write. Okay, स्वरा समझता है? नक्की लिखो आगे. अनीश काय म्हणतोय? कसं चाललंय लाईफ? हा done. And now, MTG last मी कोणता गेला होता?
8.
Sure? नक्की? हाँ? हाँ, एक कप खो गए थे.